is Algebra 1, Lesson 54. We're going to be solving systems of simultaneous equations using substitution. So it's a lot of big words here, but it's pretty simple. Basically, there's something that's called the substitution axiom. Sometimes it's also called the substitution property of equality. And this axiom is basically something that mathematicians accept to be true. And it's very simple. Basically, if there's a couple things that are equal to each other, then you can substitute them. So that's like if A equals B, then A can be substituted for B. And vice versa. B can also be substituted for A in any mathematical expression or equation. And the mathematical equation or expression is not going to stop being true or stop being false because A and B are the same thing. So let's practice that. We're going to look at a system of simultaneous equations, and that's 2x minus y equals 1, and then x equals negative 3y plus 11. So a system of simultaneous equations means that there's two different equations, there's two different variables, we have x and y, and basically there is a solution, there's one value of x and one value of y that satisfy both of these equations. And so in order to find what those values are, we're going to use substitution. So the second equation, you can see that the x is already isolated. So the x is already by itself, and that makes it easy to use substitution. So what I'm going to do is this 2x minus y, I'm going to substitute in this value of x, right? Since this thing is equal to x, I'm going to plug it into the first equation. So 2x becomes 2 times this whole thing, negative 3y plus 11 minus y equals 1. So all I did was substitute this value of x into here. And now I can simplify using the distributive property. 2 times negative 3y is negative 6y. 2 times 11 plus 22 minus y equals 1. And now I just have to combine like terms. Negative 6y minus y would be negative 7y plus 22 equals 1. Then I have to move this 22 over by subtracting it from both sides. And I would get negative 7y equals negative 21. Solving by division, I would get y is equal to negative 21 over negative 7, which is positive 3. So y is equal to 3. So I solved for y by substitution. And now that I found the value of y that works, I'm going to plug this value of y into the second equation. So x equals negative 3y would be negative 3 times 3 plus 11. And then I can just evaluate that. That would be negative 9 plus 11, which would be positive 2. So now I have the value of x and the value of y that satisfy this system of simultaneous equations. And most of the time we write our answer as an ordered pair. So we would write our answer as, we know that x is the first coordinate and y is the second. So in this case our answer would be 2, 3 in parentheses, just like an ordered pair. All right. Now we're going to need to try some more examples. You're going to do these ones on your own. So the first example we're going to try is solve this system of equations. 2x plus 3y equals negative 13 and y equals x minus 6. So go ahead and pause the video, write these down, and use substitution to solve for x and y. So checking the answer for this example, what I did was plugged in y into the first equation. I plugged in the value of x minus 6, and then I solved for the value of x, and I got x equals 1. And then when I got x equals 1, I plugged it into the second equation and got y equals negative 5. So my answer is 1, negative 5. Let's do another example. And for this next example, you're going to solve this system of equations 3x plus 2y equals 3 and x equals 3y minus 10. So again, use substitution by plugging in the value of x into the first equation and then solve. Go ahead and pause the video. So checking this example's answer, I plugged in the value of x into the top equation and I solved for y, which was 3, and then I plugged 3 into the second equation to get the value of x, which was negative 1. And then finally write the answer as an ordered pair, so we get negative 1, 3. Let's go ahead and do one more quick example. So for the last example, solve this system of equations negative x minus 2y equals 4 and y equals negative 3x plus 8. Go ahead and solve for both x and y. All right, checking the last answer for the last example, we use the value of y, plug it into the top equation, and I get x equals 4. Plug that into the second equation, and I get y equals negative 4. So my ordered pair is 4, negative 4.